Welcome everybody. Welcome everybody. Let me welcome you today in our next Froggeeks Green Tech talk. Today it's my great pleasure to welcome a special guest. Right time before the European Bamboo Expo starting this weekend. For those of you that are going to Dortmund, let me welcome Dr. Pablo van der Lugt.
Thank you, Jana. Pleasure to be here.
Thank you so much for being with us and for taking the time. Just a little intro on Dr. van der Lugt's background, so you have a little bit more idea and understanding where we are coming from in our discussion and the talk today. So Dr. van der Lugt is a distinguished, renowned TEDx speaker and biobased building specialist from the Technical University in Delft. He has expertise in sustainable architecture, circularity, and of course, biobased materials. He's also the board member of the highly influential Built by Nature Fund and the owner at the Green Matters Consultancy. He's also the author of Tomorrow's Timber and Booming Bamboo, which I believe we get a chance, if you have it by any chance next to you.
Definitely. Just a new one. Just the totally revised version just came in this week. So I'm really pleased by that.
Brand new. So, and he's also, as we already indicated in the little intro, he's also World Bamboo Ambassador. So with this, once again, welcome and thank you for taking the time. I think we all can get ready to be inspired about your insights and ideas. You're also one of the leading keynote speakers on the European Bamboo Expo. So really, it's a lot of elements that come together. We are a green tech marketplace looking at sustainable building, at sustainable living, and bamboo is a super interesting material in so many ways. And maybe you can tell us, just to make a slow start into the discussion, into the conversation, what brought you to this journey of, from architecture into sustainable building, into bio-based materials, and now we see bamboo coming up. Maybe you can tell us more about that.
Yes, I would love to. Well, actually, I was educated as an architectural engineer in Delft University. And then first I was intrigued by sustainability, but nothing really captured me. I did like materials, and then I got the opportunity to do an internship at the National Bamboo Project in Costa Rica, which was totally coincidence. And when I was there and I saw the guadua species grow in the plantations, and half a meter a day, and such a strong building material, a lot of houses were made there that survived earthquakes. And at the same time, no one wanted to live in a bamboo house. So the stigma there, as the bamboo is a poor man's timber, was really apparent. So that struck me, and I was intrigued, and I decided to do my master thesis about the bamboo stem as a potential building material for Western Europe. And then, well, I learned a lot, but also that there are a lot of impossibilities on using the stem in Western climate. So then I focused for my PhD on engineered bamboo. All kinds of materials that you actually also see in the back and the ceiling and the floor by coincidence. And well, then finishing my PhD about the environmental impact of engineered bamboo compared to incumbent fossil building materials, I found out that most impact is to be made in industry, not in academics, sadly. So no one reads a PhD thesis, and I'm like to make impact. But that's why I decided to move 15 years ago to the industry as a consultant, focusing on bamboo, but also on other bio-based materials such as mass timber, CLT, and glulam. I think bamboo and mass timber are friends, not foes.
Understand. So when talking about the impact of bamboo in general, we know there is a lot of discussion on climate change, respective measures. How can we have the impact that we need? What is your perspective? Where do you see bamboo? What is its role? Where do you see it, making a change or making an impact there?
So in general, with all bio-based materials, if they come from a managed source, well-managed source, it's an unlimited resource. But we all know bamboo grows very quick. So if it's managed well, you can activate the growing speeds, and it will produce more feedstock than almost any other material. So that's the one side of things. The resource itself is also super versatile. So with, as you probably know, and many of your viewers, but one size fits all. You can use the fiber or the strip to make building materials, but you can also, for example, use it for textile, for pulp, for paper, for energy. purifying charcoal. There are so many applications for it. So that makes it possible to substitute synthetic materials that often have a high carbon footprint. For example, window frames that are made of PVC, you can make it out of laminated bamboo, or the flooring, or well, in the future, probably also complete constructions where you can maybe replace concrete and brick and steel with a super high carbon footprint and replace it for bamboo. So one is the resource scarcity, and the second, and I also touched upon that, is obviously the carbon sequestration benefits, because it grows quick, it captures more CO2 than almost any other material. And as long as the material is used, it will lock the CO2 in this building material. So that is important. Then the durable building products will be a carbon sink, but also the forest will remain forest. As most people know, you just need to harvest the 4-year-old bamboo stems, and then every year you keep the forest alive, and you thin it out every year. So which means you activate the growing possibility of the bamboo, capture CO2, but also there's a carbon sink in the built environment, but also a carbon sink in the forest itself. And those two carbon sinks together make for quite a big, well, carbon mitigation potential through bamboo.
Now, in many of your talks, I mean, timber is quite a topic. Now we see bamboo kind of not supplementing it, but being the other material that has very similar properties. Do you see it this way? What do you think about the statements like, is bamboo going to replace wood, or what's your thinking about that?
Actually, I don't think it should replace wood in general, because wood from sustainably managed forest is also a carbon negative material, just like bamboo. So you only should substitute wood on those places where, for example, a lot of unsustainable wood is used. For example, tropical hardwood from illegally harvested. That's an example. But I think it's better if we focus our attention on those applications where you have synthetic materials that are being used. Synthetic materials are non-renewable, and they have high CO2 emissions during production. So the example I gave about the window frame, but you can also do it for many other applications. For example, cladding. We see a lot of wood plastic composite cladding with a lot of plastic, or you see aluminum sheeting. If you can replace that with bamboo or wood from sustainably managed forest, then I think you will have a really great benefit. And I think you have to look at those properties that bamboo has, which are unique compared to other materials. So for example, for the cladding, you have the compressed bamboo, which has fire class B. And this is impossible to reach with wood. So in that case, the bamboo has an added benefit compared to wood, and you don't need to add fire impregnation. And then I guess it's in this case, it's better to use bamboo compared to wood.
This is beautiful because it's really like telepathy. So you kind of answer the questions that I would like to ask. So it's amazing. Thank you so much for that. And just maybe going back to what you said in the previous part, there are also some limitations or challenges. At least that's what we hear from the industry, from architects working with bamboo. What would you like to maybe pinpoint as an architect, as an engineer, as being deep in the building industry, to architects to watch out for or to consider?
Yes, there are of course many bottlenecks that you need to overcome when you have a new material that's being introduced. There's lack of knowledge about it. There's lack of technical knowledge. Of course, often also lack of standards. Sometimes you need certification to enter a market. For example, especially for bearing structures in Europe, you need to have your material certified following an ETA, an European Technical Approval. So showing, testing that all the strength properties are meeting European standards, and you have to show that, and all this testing costs a lot of time and money. Still, the sector is weak, so there is not a lot of this money available. So this is one of the challenges. I think also a lot of designers and architects don't know about the possibilities of bamboo, even with engineered bamboo, which is quite a well-known material. Many architects are still surprised that when I talk about the bamboo stem or bamboo, they think about the bamboo stem, which I have to say, the bamboo stem is a beautiful material, but even more difficult to use in Western climate and with certification because of every bamboo stem being different. However, I'm a big fan, so I see this as an important challenge to also see where we can use the bamboo stem in the Western built environment.
Mm.
Can I think of other, maybe probably the life cycle assessment and carbon footprint of materials. Well, I work one day a week still for Mozo International, and we have developed an environmental product declaration, which really exactly shows what is the CO2 emission and the environmental impact of a product from cradle to grave. So taking every step into account, the glue, the transport, energy use, etc., and the recycling possibilities. This is also very important for actually all other manufacturers for different, especially for the built environments, because this will be more and more important in European legislation, that you have, that you can prove what the environmental impact is of your building material for the built environment. So this is still what many of the manufacturers have to catch up with. And if I look at bamboo products itself, there are also still some improvements possible. If I look at the environmental product declaration, for example, of the products of Mozo, then you see that the environmental impact of the glue is quite significant, and of transport. So it is, and actually this applies also to many other bamboo products that you need an additive or a chemical substance. For example, for the textile, you need this chemical solution to dissolve the fibers to make the final viscose fiber.
Mhm.
So almost for every major potential bamboo product, you need some kind of chemical, and these chemicals need to be either fully bio-based, but especially more eco-friendly with a lower toxicity and lower environmental impact. So this is for the additives, but this also applies to the transport. We get a lot of the giant bamboo still from, of course, Africa, China, Latin America. And this is why I think it's super promising that you see many startups and scale-ups such as Bamboo Logic planting a lot of bamboo in Europe, is south of Europe, but now also in Belgium and Netherlands. Of course, the bamboo will be thinner, and we have to develop and design new products, maybe more composite products or with using the unique properties of the European bamboo. But this will also help lower the transport distance and the related environmental impact. So there are many challenges, but I think this is also fun. We're at the front of a new transition with bamboo, and also looking at locally sourced European bamboo.
Essentially, as you mentioned, it's a new market. It is kind of forming now, and we are somewhere in the middle or at the beginning of it. And you mentioned also the application of bamboo in Western climates, or yeah, in different climates. Maybe you can tell us more about that. What's your considerations over there?
So do you mean the bamboo stem or engineered bamboo?
Whatever you prefer to highlight more. I mean,
yeah. So if you use the engineered bamboo without any treatment, and this also applies to the stem, outside it will deteriorate because of the fungi, the rain, the moist climate, especially in Netherlands and north of Europe. It is quite wet, humid, difficult circumstances with a lot of fungi. So you need to give the both bamboo, the stem or engineered bamboo, a treatment. One of the treatments that I really prefer for the engineered bamboo is not to add biocides, not impregnation with chemicals, but to do thermal modification. This is a technology we know from the wood industry, thermally modified wood, or thermal wood, in which very low durability wood, pine species, etc., are modified, and as a result become very stable and become super durable, rot resistant. You can do exactly the same with the bamboo. And the negative part of the modification is that the wood or bamboo becomes brittle. And then the nice thing of the bamboo is you have the strips that are then after that compressed. And because of this compression, the final product is actually quite strong still. So you don't have the downsides of a thermally modified wood with the thermally modified bamboo. I don't know if you can see it here at the back. There are a couple of samples there with the thermally modified bamboo. It has the dark brown color. And then it will UV degrade and get a very homogeneous gray color if you don't lacquer it. But many architects really like this. So this is one of the considerations for the use of bamboo outside. If you want to use the stem outside, well, we know the typical design basics that many of the bamboo architects always tell us. Keep the bamboo stem off the ground by putting it on a socket and take it out of direct sun and rain by giving it a hat. If you do this, then you have more probability that the bamboo stem will last a little bit longer. But as it grows so quickly, and it's the only bamboo material actually worldwide, building material that you can cut and use directly, to super environmental friendly building material and designed by nature, hollow with the strongest fibers at the outside. So in one sense, it's a pity that we have to make engineered bamboo, whereas we already have such a super efficient building material. So I'm really invite all designers and engineers, and there are many of them also showing examples in the book, to see how you can make connections with bamboo so that you can standardize construction based on the tapering, irregular building material. This is the challenge. So the solution lies in the connections.
In the connections. Wow. Now the connections are always key. So thank you so much for highlighting that.
Yeah.
And we need to come back to the point where our viewers and the listeners can order the book. That would be very important. So we can also embed it in the description for later. And you know, now all the maintenance you mentioned also potentially what I read between the lines, maybe repairability could be a topic or an option. That could be a benefit of a locally sourced, highly renewable, fast-growing material that you can just change if there is something happening. Now, when we talk about the cost connected to that, the numbers, how does it the Germans have a saying, like, how does it, come together or make sense? So what is it for you? Where is it economically?
So what will help, of course, with the European grown bamboo is that you can eradicate the transport and also the transport costs. This really helps. Of course, growing bamboo in Netherlands, for example, the ground is, how do you say this? The area, the land itself is super expensive. So you have to relate this. So it's actually best to plant bamboo on poor agricultural land. I think this is a good idea anyway, that you never compete with the food production. For example, Bamboo Logic plants in the south of Portugal in a very dry and arid area where nothing else grows. And I've been on this plantation actually in October last year, and you see that it grows back, and eventually also it becomes more moist. The water table returns. There's a humus in Dutch. The fertile soil is coming on the top layer back. Canopy closes. So here you produce a lot of value for the area. And the cost, of course, always goes before the benefit. So if you grow in those poorer areas, the land is not so costly, and you can produce bamboo maybe cost competitive, especially if you do smart logistics. If you can do it by cheap truck or even by boat if possible. So you have to add all these things up, but you need enough skill. So for the European bamboo, it's still too expensive because they are all small plots. When you get more skill, and this, for example, the crowdfunding of Bamboo Logic, which now they capture €2.5 million, I believe, will help to plant more bamboo. The more bamboo you have, you can create the industry, and the industry only helps if you have economy of scale. So, of course, in the beginning, it will be still more expensive compared to incumbent materials, even compared to Chinese bamboo. But looking ahead in a couple of years with hundreds, maybe thousands of hectares of bamboo and the processing industry that we know is not so different from the wood processing industry, you can see that maybe the wood industry will also adopt bamboo and produce with economy of scale product which grows quicker, maybe has a higher yield, and in the end will be more probably add more value, but be more cost efficient. But this will take time, and this is normal in a transition to a new social norm, in this case of the use of engineered bamboo materials.
Super exciting, and also pretty much resonates with me. I mean, we all now, that are working in this sustainability related fields. I mean, we work in this transition and live with it and see all the changes, and it's not going to be easy. It's a long journey. So,
No, it's always more expensive. PV panels were more expensive 10 years ago, and now they are competitive. Electric
mm,
cars were more expensive, and now they become competitive. And the same will happen with bamboo, as long as we have front runners that believe in it and see also the. I think this is important to maybe to add that the economic damage we do, or the ecological damage, we don't monetize that in our current pricing. So
mm,
if we do this, and for example with carbon credits or other ways to LCA, you can also see the environmental cost. You see the environmental cost of producing plastics and concrete and bricks, etc., is a lot higher, and we calculate this environmental cost to actual cost, the societal cost. Then you see actually with bio-based materials and resources such as bamboo, we have actually, if you do have a far lower cost because we don't have the environmental damage.
mm.
I hope I make sense.
Definitely, definitely, absolutely. And just a quick question: what all will be covered in the Booming Bamboo book from what we are kind of also discussing? A nice conversation over lunch.
Yes,
Is
yes.
that covered also in the book, or
Ooh,
what can the readers expect?
look what is covered. You see projects, you see
Mhm.
sustainability, you see new technologies. So all we discussed is actually in there, and a lot more. A lot of more inspiring projects from Europe, but also from all over the world. We
Mhm.
talk about sustainability in the book and the carbon footprint on product level, but also on land level. We look at the history of bamboo and the industrialization. How big is the market? Latest trade data is in there. Well, the key mechanical properties of bamboo is in there, both for the stem and engineered bamboo, and also the basics of a circular economy and a bio-based economy are in there as well. Well, we didn't cover all of that in our talk now, but so there is more. But it's hard to cover a whole book in half an hour.
Dr. Pablo van der Lugt, it's very difficult because you're like a telepath, literally in this. So I think you made a perfect bridge towards the end of our discussion, of our quick talk today, which was a circular economy. That was what kind of resonated for me. So, I mean, in Dortmund, the whole European Bamboo Expo is also kind of, has the bottom line, the red line of circularity. A lot of people are talking about this.
Yes.
What's your take on bamboo building circularity? How does it come together? Maybe also to kind of tease us a little bit on your book.
Yeah, with a circular economy, of course, you have two cycles: the technological cycles, the synthetic materials like plastics, etc., that you need to close the cycle to make sure that you don't lose any of those finite materials, and the biological cycle. Now, the key is if you have a product and it is renewed in the time that it is being used, you have potentially an unlimited amount of feedstock that you can use. Um, if you produce materials that are more durable, they will last longer. And for example, in the case of bamboo, if you look at the engineered outdoor bamboo board, it grows back in a couple of years, and it will last maybe 25 to 50 years.
Mm.
Now, this is one part of the thing why I really prefer the biological cycle. The second part is in the end of life. That's why I stressed also we need to get the final chemical substances out of the bamboo to make sure that it is 100% bio-based. And then in the end of life, it can be either safely burned, but preferably we reuse it
Mm.
in another application. So you capture the CO2 for longer, because if you burn it, the CO2 is released again. So you have to look at the feedstock sides. So produce as much bamboo as possible. Then make sure it's as durable as possible. So you make really high quality products that you can maintain easily. And then also when you're looking at the building industry, if you look at the buildings, you have to make sure that you use systems that you don't glue the bamboo to the floor or something, but you have a click system, or you make it demountable with your cladding. You have all kinds of demountable systems that you can screw on and screw off. So your boards may be reusable, or you send them and they get another application. And this is also important. So you facilitate the reuse of the material. Well, and then it might last for 50 or 100 years. And we know how fast the bamboo grows. So, well, it has grown back maybe 10 or even more times during this period, as long as we plant a lot of bamboo and we manage it in a sustainable way.
So it's a fascinating discussion. I would love to have more time with you, but I know time is precious. So thank you so much for your time
Maybe in
today.
Dortmund.
Amazing discussion. We love to share the link where our readers and viewers can purchase the book. Definitely, please rock it on the European Bamboo Expo this weekend. And thank you so much to everybody.
Thank you, Jana.
Bye-bye.
My welcome. Bye-bye.